Welcome back to The Explainer. So today we're doing something, well, something pretty wild. We are going to turn a plain old computer terminal, that intimidating black box with the green text you always see hackers furiously typing on in the movies, into a state-of-the-art digital forensics lab. And here's the best part. Even if you have absolutely zero coding experience, I guarantee you're going to be able to follow along. We're essentially just using simple, everyday logic translated into basic computer commands to give ourselves superpowers. Okay, let's jump right in.
So here's the big question we're looking at today. Can you actually solve a murder using only a computer terminal? I mean, picture this. No traditional detective work, no magnifying glasses, no dusting for fingerprints, no driving around interrogating people, just raw data and a couple of command line tools. We're basically playing digital detectives today, using a few keystrokes to sift through mountains of city data and catch a killer. It sounds like straight-up sci-fi, but trust me, by the end of this explainer, you're going to see exactly how it's done.
All right, Section 1, the crime scene clues.
So, out at the scene, our detectives actually found some pretty solid breadcrumbs. First up, we've got some blurry ATM footage that tells us our suspect is a tall guy, at least 6 feet. Second, in his rush to get away, the killer actually dropped his wallet. No ID inside, unfortunately, but there were 4 very specific membership cards. AAA, Delta SkyMiles, the Terminal City Library, and the Museum of Bash History. Finally, we have an eyewitness. A barista named Annabelle saw the getaway car. She says it was a blue Honda. She didn't catch the whole plate, but she remembers it starts with L337, ends in a 9. And honestly, those 4 clues are literally all we need.
Moving on to Section 2, the suspect lineup.
So, we run a quick search in the city's vehicle database for all blue Hondas with a plate starting in L337 and ending in 9. The database spits out exactly 4 matches: Erica, Joe, Darty, and Helen. But hey, remember that very first ATM clue? Our suspect is a tall male, so we can instantly cross off Erica and Helen. Boom! That leaves us with just 2 remaining suspects, Joe, who's 6'2", and Darty, who's 6'1". The net is definitely tightening here.
Which brings us to Section 3, AWK, our data detective.
Now, to pull off a search like that, you really have to understand how a computer actually reads data. If you use a basic search tool, like the really popular one called grep, it reads line by line. It's kind of like looking at the world through a tiny peephole. It might see color blue on one line and make Honda on the next, but it totally fails to connect them as the exact same car. It misses the big picture. But AWK is way smarter. It reads paragraph by paragraph. It literally scoops up an entire block of text, a full suspect profile, and looks at everything all at once. So it can say, this one specific chunk of text has blue, Honda, a 6-foot height, and that exact license plate. It is just beautifully precise.
Let's break down how we actually tell AWK to do this, just using plain old logic. Step 1. We tell the tool to switch into that awesome paragraph mode. Step 2. We ask it to look for the words blue and Honda. Step 3, we add another condition. It absolutely must contain height 6 for our tall suspect. And step 4, we tell it to look for that partial plate. So L337, any random characters in the middle and ending with a 9. By just stacking up these simple logical steps, we've basically handed the computer a perfect digital sketch of the killer.
Now, if you actually looked at the code for this, you'd see this weird little snippet, -VSR equals ... I know, it looks like alien text. But do not let it scare you. All it literally means is record separator equals nothing. That is the magic key for paragraph mode. It's just telling our digital detective, hey, stop reading line by line. Wait until you hit a blank space and treat everything before it as one single profile. It's a tiny piece of code doing some massive heavy lifting.
All right, Section 4, cross-referencing memberships.
So now we need to search through 4 entirely separate databases: AAA, Delta, the library, and the museum. If you were a real-world detective, you'd be physically walking to 4 different filing cabinets, right? On a computer, typing out the exact digital path for all 4 of those lists is just tedious. So we use this genius shortcut called brace expansion. You just pop the file names inside curly brackets, separate them with commas, and the computer instantly grabs all 4 files at the exact same time. It's a huge time saver and keeps everything perfectly organized.
And here is where it gets really fun. Once we grab those 4 files, we use a symbol called the pipe. It looks like a straight vertical line on your keyboard. I want you to picture a literal physical plumbing pipe here. What it does is take the massive flow of data from those 4 membership lists and literally pours it directly into our next search tool. That way, we aren't printing thousands and thousands of names all over our screen. We are piping the raw evidence straight to the interrogator.
So, pulling it all together into our final command, we use a tool called cat to merge all 4 lists into one giant stream. We pour that stream right through our pipe symbol, and then, on the other end, we use our search tool to look for our prime suspect, Darty Henv. We add a little flag, -C, which just tells the computer to count the matches instead of spitting out names. So we are literally asking, search this giant merged pile of data and count exactly how many times Darty's name pops up.
And finally, Section 5, Case Closed. Okay, moment of truth. The result from our terminal, it's just the number 4. Now, think about why that is absolutely huge. We found exactly 4 membership cards dropped at the crime scene. We searched exactly 4 databases. So if the computer spits out a 4, it means Darty Henv is on every single one of those lists. AA, yep. Delta, yep. Library and museum, yes and yes. It is a perfect, flawless match. This just brilliantly shows how conclusive this kind of digital data can be. The math doesn't lie, right? By just cross-referencing basic stuff like height, car make, and some loyalty cards, using absolutely nothing but a black screen and some clever logic, we officially zeroed in on our target. Darty Henv is the killer. Case absolutely closed, and we didn't even have to get up from the desk.
Which leaves us with this final thought for today. We just saw how tools like awk and some incredibly simple logic can filter and solve these crazy complex puzzles in seconds. And you didn't even need to be a programmer to follow it. It's really just about how you ask the computer to look at the info. So if a few lines of basic code can catch a fictional killer, imagine what else you could uncover, organize, or simplify in your own digital life. The terminal isn't just for movie hackers, guys. It's a wildly powerful tool for anybody who wants to take control of their data. I really hope this explainer sparked a little curiosity for you today. Keep asking questions, keep exploring, and we'll see you next time.